Whenever we're factoring, the number one rule every time is, do they have anything in common to factor out? If they do, if anything's divisible by all three or they all have an x or something, I have to do that first. Or the odds of me getting to the right answer are very slim. So for instance, let me take a look at number 1. I look at all those, and I heard it over there. They're all divisible by 6, and if I'm not sure, use the calculator. Do they all have anything else in common? They all have an A. Okay, I have to get those out of there before I start. Once I do, here comes my next job. My next job now is to figure out what I times this by to get each of these terms, because that's what's going to go in here. Okay. I already got the 6. I got 1A, but I need to get to 3. I need 2 more. 6 times what gets me to negative 42? If I'm not sure, punch in negative 42 divided by 6 into your calculator. Okay. I got 1A. I need 2. I get that in. 6 to get to positive 36. I need a 6. But I already have an A this time, so I don't need any more. Now, sometimes that's going to be enough. That may be all I can do. I might be done, but I need to check. So I take a peek for a second at what's left in the parentheses. My rule is, okay, if I look in the parentheses, okay, 3 terms, no number in front of x squared, or in this case, a squared. Okay, we use the diamond. Again, the diamond is the one where we multiply by the number on the end and add to get the number in the middle. So what I'm going to do, I'm going to make myself 2 sets of parentheses. I get to start with the A on each one. So I need to think about a couple of things because there's some clues here that can help me. If it multiplies to get a positive, one of 2 things is going to happen. They're either both going to be positive or they're both going to be negative, because that's the only way I can get a positive product. Well, how do I know which one it is? Well, the add number is negative. So these both have to be negative. And then my last job is to take 6 and say, okay, let's see, to get 6, I can do 6 and 1, I can do 2 and 3. But which pair of those adds me up to 7? 6 and 1 do. And then my last thing, it's just a little one though, that stuff I pulled out before, that I factored out before, just gets put back in the front. Now, is something that large going to happen every single time on these, where I have to factor something out? No, but did Hardy purposefully put several of those on here to get you thinking about it? Yes. And most of the time, if there's something that divides out, it's going to be the number that's in front. Maybe all these are divisible by 4. Divisible by 5. Maybe they all just have an x. You've got to start looking for that stuff because that's basically what factoring gets to be about. Okay? The other one that I want us to look at, because we saw factor out a value, we saw what to do if there's no number in front of the squared term. What if there is? So let's find one of those. I want to find a nasty one. Ooh, 7, that looks bad. So let's come down to 7, because I want to make sure we got a good example of everything here. Okay, 7. First thing I do, make sure that there's nothing in common. Does anything divide into 7, 39, and 20? No, I'll give you a heads up on that. And it's got to be all 3. It's not 2 out of 3, but all of them. So if that doesn't work, here's what my plan of attack becomes. I take whatever number's in front. I slide that down to the end. Because again, it says on my half sheet, use slide and divide. I'm like, okay. Now again, if you didn't do the half sheet before where you wrote down on the back how to do one of these, maybe you write this down and then you put it on the back. So when you do the retake or the quiz on this, you can do this. 7 times 20 is 140. Now, some of you already, your eyes are getting big going, my gosh, I don't know what to multiply to get 140. Well, you don't have to know off the top of your head. That's what the calculator's for. So, I'm going to start making a list. Now, cool thing, these are both pluses, so I know they're going to add up. So, what I'm doing is I'm trying to find two numbers that multiply to 140, but that add up to 39. Well, that's too big. That didn't work out for me. Let's try something bigger. Let's try 4. Ooh. 4 and 35 is 39. 4 times 35 is 140. Cool. So I write those down. But remember, this is called slide and divide. We did the sliding. Haven't done the dividing yet. So I'm going to divide those numbers by that front value, my p squared coefficient. If it goes in nice, 35 divided by 7 is 5. Cool. What if it doesn't go in nice? What if I, punch it in my calculator and I get a decimal? Do I write that? No. Do I leave it as a fraction? No. Yes, it swings back to the front, goes in front of the p, and I get my answer. So for 7 and 8 and 9 and 10, this is the route you're going to go. Up on the top, 1, 2, 3, 4, those all have something you have to take out. And then 5 is actually pretty straightforward. But again, when you're doing these, you've got to keep telling yourself, first thing every time on a factoring problem, is there anything to factor out? Every single term has to have that thing you can take out, whether it's a number or a variable. Otherwise, use the examples you have on here plus what you're working on. Again, it can be something that takes a little while. It can. But you've got to keep playing with this. If your multiplication skills are weak, you got to keep playing with the calculator then. You can't just shut it down. It's not going away. So that's one thing we're going to take a peek at. All right, so now our focus is going to turn to the quiz preview. So we kind of get to see a lot of things today. So we're like, oh, back to equations and fractions. I hate this. Okay, before you freak out, you have options here. 4 different numbers down here. My goal normally would be to find what's called the least common multiple. The smallest number that 2, 3, 4, and 6 all divide into, okay, which is 12. But I'll tell you in advance, because we're going to go ahead and use 12. If you forget, or if you look at it and you're like, I can't figure this out, you always have the option of multiplying these numbers together and using that number out front. You'll get bigger numbers, but you'll still get to the right answer at the end. So, by using 12, again, here's how this works. Multiply by the number on top, and then divide by the number on the bottom. So 12 times 7 is 84, divided by 4 is 21. Fraction gone with the first one. 12 times negative 1 is negative 12, divided by 3 is 4, negative 4. And I keep working my way through. 12 times negative 5 is negative 60, divided by 2 is negative 30. And finally, 12 times 3 is 36, divided by 6 is 6. Notice, no more fractions anywhere. If I went through and did get fractions somewhere, I did something wrong. Okay, but it's got to be the same number that I multiply by all the way through. Once I do that, then we just roll with it. So I want to get all my x's together. Since they're on opposite sides of the equals, I need to do an opposite. And don't worry if you get answers that are fractions and stuff. That can happen. Again, my goal is to get x by itself. And then we just divide both sides by 51. And again, it's the number with x that we're dividing both sides by. Okay, I don't want 51 over 10. That would be a different answer. Wouldn't quite be right in this case. Okay, so that's kind of one of our arch nemesis that we're going to keep fighting through. We're going to get there because fractions are just part of what we do in here. Now the next one, oh, this one. Okay, we're going to solve for b. Now again, my first job, okay, I'm trying to get that alone. Whatever is furthest away from the b, this 4x is, that needs to go away first. So how am I going to get that out of there? Multiply. Because that'll get rid of the fraction part. Makes me a happy camper. So I'm like, all right. Halfway there. Again, I'm trying to get b by itself. Yes. Add the 3a because it's minus 3a. And yes, it's going to look weird, but it's going to be right. b is by itself. I'm a happy camper. But again, it's step by step when you're going through. Even if you're not sure on one like that, instead of leaving it blank or drawing me a frowny face, try doing some opposites, because if you do a couple of steps right, you're still going to get some credit. Anything's better than nothing. And then our final one, now that we've been doing our own little thing with factoring here, this should be easier actually. Solve for p. Now be careful. There's two terms with p. P cannot be part of my answer. So we're going to factor what those two terms have in common. Ooh, it's p. So I take the p out. Okay, the first term, I've already got p. Still need the 4m. Now here you're like, well, I already got the p, so I just put nothing? No. We need a 1 to hold the place. And the reason that worked well for me is, now notice I went from 2 p's down to 1. And now I've only got one step to get this p by itself. Yes. Since I'm multiplying by 4m minus 1, I'm going to divide both sides by that. And notice my p is now by itself, and I'm happy. It won't work any other way, because somebody will usually ask, well, can I plus p and then divide by 4m? No, because then p is part of my answer. And the variable that I'm solving for can't be part of the answer. It never works. But again, when you're seeing these, there's more examples of these. There's more videos and stuff like that online, and even in your notes if you still got them somewhere, some prior assignments. So that kind of covers our equation part here at the start. So then I move down a bit. Okay, identify the vertex, slope, mercy, the domain and range, and graph. Okay, so absolute value functions from last week. When I'm looking for my vertex, there's a couple of ways I can do this, but I really want to simplify this. Normally when we do these are in a form that looks like this. Now, that may not make a lot of sense at first, but let's figure out what the parts are, and then it may. I look at this, my vertex is HK. My slope is the A. So everything I need to draw this comes from this equation. So I start to look and I'm like, okay, so H is the number in the absolute value with this X. Oh, wait a minute, there's no number there. So what value do I use for my h? 0. If I don't see it there, I use that. And then k is just the number that's on the outside. So my vertex is at 0, 7. Because I plot it just like I'd plot any point. My slope, even though I didn't put a blank for it, and I should have, is -3. Or I can make a fraction out of it if I want to. Now here's the part that gets a little crazy. When you think of negative slope, you think, okay, so I go down 3 and over 1, and down 3 and over 1. And you'd keep going that way. But this isn't just a line. Okay? That negative just tells me this opens down. Because remember, these guys look like V shapes. So I've got to go down and right and left so I get my V shape. Okay, got to have the arrows because it keeps on going and going, because that's going to come in handy when we get to this last part. So I'm going downward and I say, okay, domain. Domain is my x values going from left to right. So you're like, okay, well, this arrow keeps going and going and going, and so does this one. Well, if this keeps going out and to the left forever, forever we signify with infinity. Negative infinity, because I'm going to the left. I'm becoming more negative. Then to the right, it keeps going out and out and out to the right forever. To positive infinity. Whenever we see arrows, there's lots of infinities going on. And I have to keep that in mind. Now my range is my y values. And it's my y values from the bottom of my graph to the top. You're like, well, the bottom, it's going down, 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 down forever. Okay. But unlike domain, is it going up forever? No. It goes up until I get to this point. What's my y value at this point? 7. And that's where it stops. And that's going to be true with all of these all the way through. So let's see. Let's see if we got this. What's my vertex on number 5? Thought I heard it. You're like, now wait a minute. That says +2. Why'd you put -2? Because in here. Yeah, this tells me it's the opposite of h. My h value is the opposite of what I see here. So if that says plus, I'm going to use minus. If it says minus, I'm going to use plus. So -2, -3. Put my dot. What's my slope this time? 1. If I don't have the values for my h or k, if I don't see one, those are 0. But otherwise, it's going to be 1, which tells me my v is going to open up. So I'm like, okay, so up 1 over 1, up 1 over 1. And I got to do it both directions, up and left, up and left. Should make a little triangle or a little V shape. And I connect the dots with arrows. Got to have the arrows. But this is the part where this should start as I'm getting to the second one and the third one getting a little bit easier. So let's see. I'm staring at this. I'm going to domain. My x is from left to right. What's my domain going to be on this one? Negative infinity to infinity. Because again, this arrow is going to keep going out to the left. This arrow is going to keep going out to the right. And I can keep going that way. Now range. Okay, this time I got to be a little more careful. Bottom to top. Super. Okay, -3, because this point's y value is down here. But it goes up forever. negative 3 to infinity. Nicely played. And so as you're doing these, there's several things I'm keeping in mind, but again, it's good practice. All right. Ooh, I'm going to get sneaky. Try out number 6 for a minute. I'm going to go ahead and get it done here. And then we'll see here in just a moment if we are getting the same thing. Use those examples that you've had for the first couple to try and see if you can get this one to work for you. And then hopefully in a moment here, when we get back together, we'll all have the same thing working. My slope is 2/3, so up 2 and over 3, up 2 and over 3 in each direction. My domain, now notice something with my domain. Whether it opens up or whether it opens down, the domain's the same every time. So that should be the easiest part of these when you're graphing them, because it's always going to be negative infinity to infinity. But my range, again, is bottom. Okay, here's where I'm looking at the y value with the range. Don't use 3, that'd be my x. I want y, and then up to infinity. So again, that shouldn't end up being too bad as we're taking a peek at that. Oh, and there's some little things that can kind of start to get you on these.
I got everything right, except I have the thing pointing down.
Gotcha. So, okay, we're going to slowly start going into piecewise here. Now, when I see all these f functions down here, the number inside tells me the x value that I'm testing out. To figure out how this works, I have to look at the inequalities first, because that's going to tell me which one of those I'm plugging this into. Because this value is only going to work for one of these, not both. So like if I plug in 1, is 1 less than 1? No. Is 1 greater than 1? No, but it is equal to 1. So that tells me this one works. So I come over and I plug in the 1 in that expression. I don't get to do both. I have to choose. So negative 1 minus 3 is negative 4, and I'm good. And that's going to be true all the way through with these. My x value, okay, negative 2/3. Let's see. Is negative 2/3 less than 1? Yes. So, we got to plug it into the fraction one. Okay. 2/3 times negative 2/3 plus 2. Now, I'm going to do what I figure most of you will do. You're like, yep, I'm going to the calculator. You know it, Hardy. Okay. Here's what I want you to do if you go this route. Make sure you use parentheses when you're doing the fractions. I prefer the fraction. So what I'm going to do, let's see if this works for me. If I do this, hit enter, and then do math, enter, or go to my fraction, this is what I prefer. If you plug in a fraction, I'd really prefer getting a fraction out. 14/9. Because what basically any scientific calculator, the calculators in here anymore, will do is they'll get it into a fraction form for you. If it doesn't, I guess you can go back to the decimal if you need to. And then finally, okay, 4. Is 4 less than 1? No. Is 4 greater than 1? Yes. So plug in the 4 where the x is in this bottom expression and get to the answer. And again, there's lots of practice of this in a lot of places, so it's not something that should be too bad. All right. Our next nemesis. Oh, there's lots of them. Piecewise function. Woo! Okay. Remember, we're going to let the calculator help us immensely here. So, first job. Get into y equals once I turn the calculator back on. If there's something in y equals, clear it out. Type in your first expression. Don't do both at the same time. So punch it in and hit second graph. We want the chart. So here's where we get going. We're going to get this. That inequality tells you where your line has to start. You don't get a choice. I'm starting at 2. But here's the question. X is less than or equal to 2. So if I start at 2 and I'm going on a number line, less than, am I going left or am I going right? Less than, I'm going left. So I'd look at 1 and 0. I need 3 points to make my line. So less than, I use values that are less than 2. So I pop the calculator back up. And I go, okay, so at 2, I'm at 2, 0. Okay, 2, 0. Put a little dot. And 1, 2. And 0, 4. Okay, so I got these 3 little dots. So now what? Well, since it's or equal to, we're going to fill that first one in. We're going to make it kind of big. And then we connect the dots. And that's all I'm doing with piecewise. It's plug it into the calculator, get the values I need, connect the dots. Same thing on the next one. I'll clear the old one out, type in the new one, -1/2 x minus 2. I need the parentheses. Unless you have a calculator, they have the fraction button for that too. Again, I'm starting at 2, but now I want the values that are greater than 2 or to the right. So I'm going to use 3 and 4. So I go down here. I'm like, okay, so 2 is at -3. Put a little dot. Ooh, yuck. 3 is at -3.5. I can do this. Just in between. Yeah. And 4 is going to be at -4. Now the only thing left I really have to pay attention to, because I know I'm starting at 2, is that I'm going to have an open circle at 2 because it's not or equal to. So I'm going to make this one as big as I can here. And then from there, I connect the dots. Not bad. Not bad, not bad, not bad. But again, it's all about doing it in pieces. And some of you got homework from these. You could go back and try the questions out to see if it's going well or not. And we've seen these on prior quiz previews as well. All right, solve by showing work, state the solution in interval notation, graph if needed. Okay, job 1, isolate your absolute value. If there is stuff over there when you start, it needs to go away. Once that part's done, I need 2 inequalities. First one, I just leave it where it is already at.
Sorry to bother you. Any chance you could key that or have a key that you could take a copy to the sub later?
Copy what I see. And then for the second one, flip the arrow, change the sign. Once I have that set, I go ahead and I solve both of these. So I add my 6 over. I add my 6 over. And to me, it's a good idea to make a quick sketch of this so I know what the interval notation is going to look like. So let's see here. Okay, I still have to have a little bit of an idea what's going on though with some of these things. So I look and I'm like, okay, x is less than 11. Less than goes left. So that would go kind of like this. x is greater than 1. Greater than goes to the right. So they're going to like come together in the middle here. By seeing a picture, by making it visual, now when I do my interval notation, which is left to right, just like my domain is, I start at 1, go till I stop at 11. I'm done. Not a bad deal. So you see where the benefit can be from making that quick little sketch. Now, 12, already by itself, good deal. So rewrite it for the first one. And again, I got to have both of these. If I lose one of them, I'm missing half the problem. For the second one, again, flip the arrow, change the sign. And I go through my process. So I'll minus the 1 over. Then comes the ultimate, am I paying attention? I got to divide both sides by -3 to get the x alone. What happens when I divide both sides by a negative with inequalities? Nice. Arrow switches. And if you wanted to go to the decimal here, like -0.66666, you can. Same deal over here, minus my 1 over. Divide by a negative, which means I have to flip the arrow. And again, if you wanted to go to the decimal, 1.33. I'll put them below here, so in case you want to do that, you can. Thought I heard a question. Yes? No? No? Make my sketch. So x is less than or equal to -0.67. Less than or equal to goes to the left. X is greater than or equal to 4/3. Greater than goes to the right. And this is going to be one of those really big interval notations. Because remember, when I'm going from left to right, and this arrow is going forever to the left, I got to start at -infinity. And I do that until I get up to my first point here at -0.67. I close it up, but I'm like, wait, there's more over here. So I use the U to bring them together, start up again at my 1.33, and I head forever to the right. So if they're going opposite from each other, that's a really big interval notation. If they come together, it's not quite so much. So you're like, okay, all right, I kind of see the absolute value stuff going, okay. Next one we've talked about before, we're just going to do a little shortcut. I want a domain of 0 to 5 and a range of -1 to 4 with a function. What we've normally done is we've taken our x and our y, our first values, made a coordinate out of them, and I've taken my second x and y value, made a coordinate out of them. Because all I have to do then, if I do that, so first x, first y, second x, second y, is plot those two, 0, -1, 5, 4, and connect the dots. Domain 0 to 5, range -1 to +4. And that's it. I'm just drawing a picture. Just drawing a line to get those 2 points in. All right. Almost to the end. Ooh. More graphing. Okay. Graph an example of a function that has a domain of -infinity to infinity. Wait a minute. Where have I seen that before? Oh, these guys. -infinity to infinity. Okay. And a range of -infinity to 6. Check out number 4. it's almost exactly what I want, except I want this to be 6. So I'm going to move this point down. It's okay to use advantage of earlier parts of a quiz to make this work. So if I put a point up at 6 and just have an absolute value that's going down, forever left, forever right, there's my domain. Range is negative infinity, down forever, up to 6. So if you get stuck, start flipping back through your quiz sometimes. Sometimes it's amazing what you'll find for answers when you're doing that. Now, I'm going to go in a weird order for a minute. So trust me on this. I'm going to go down to 19 and 20 and come back up. Describe how the graph of each function is related to the graph of h of x equals the absolute value of x. In other words, what are the transformations? What are the shifts? Remember, whatever's inside the absolute value is my left or my right, but it's the opposite of what you think. So what's inside is always my left, right, the opposite. So here, that's going to be right 2. And the guy on the outside is always my up and down. But he gets to stay the way he is. So up and down on the outside, left and right on the inside. Then we get to go back for one last dance with factoring before we get to tomorrow. So I look, again, I can't stress this enough. When you're factoring, first rule, anything in common to factor out or that divides into both. Anything in 15? 4 and an x. So once I take out the 4 and the x, 4 times what to get to 24? X. 6. I'm getting ahead of myself. X times what to get x squared? There's the x I was looking for. Get my minus. 4 times 4 would be 1, and I already have my x. That's as far as this one goes, and that happens sometimes. I'm going to skip the diamond problem for just a minute because I want to make sure we get to these last ones because I know I'm getting close on time here. You're like, wait, I didn't see one of these before. They don't have anything in common. Okay. Are they perfect squares? Now, we did this before, too, where we wrote the perfect squares on our help sheet. That would come in kind of handy right now because I look at these, 25 and 64. Ooh, they're both on the list. Okay. So whatever I multiply to get 25, 5, to get x squared, x. To get 64, 8. To get y squared, y. And because it's a negative product, because I would multiply to get negative 64, I have to have one of each. I can't put minus minus. It won't work. And then the other two are the classic ones that we talked about before on the retake part at the beginning of this. Multiply to get the number there. Add to get the number in the middle. Multiply to get a positive, but add to get a negative. That's a big hint. They're both negative. And 7 and 4. Oh, don't disappear right now. And then the last one is going to be a slide and divide question. So here's what I'll do for you on the slide and divide. I'm going to give you the answer. It's your job to work through it until you get to it. Okay, that's what you should get at the end. So again, the quiz tomorrow will look like this. You can still use your factoring breakdown sheet. But again, look at this stuff. Watch the video again. Go do something else. If you sit and do nothing before tomorrow, it will not go better.